what you have is zero, including yourself. Zero. Now, I have had a student once tell me, I said, well, it comes down to this. Either at least one unconditioned reality exists, because both hypothesis F and hypothesis not F must be false under hypothesis not you are, the hypothesis that no unconditioned reality exists, or you don't exist. And my student said, well, I don't exist. At which point I said, in that case, your opinion doesn't matter anymore. You're not around to express it. If that's the case, all humor aside, if that's the case, then at least one unconditioned reality must exist. Now, what we got to do now is we got something. This is fascinating because really, when you look at it, you got to ask yourself, well, what must an unconditioned reality be? I mean, what is one of those things? And as we'll see in a moment, it has to be absolutely simple. It has to be unrestricted, and therefore it's going to have to be one and only one, or what we call absolutely unique. Now, I got to prove that in 3 different proofs, but it's going to be a little turgid here for a second, because I'm going to have to explain a notion called simplicity. And once you see this notion of simplicity, and you see absolute simplicity is the same thing as being unrestricted in power or act, just like St. Thomas Aquinas said, then you'll get it. But give me a few minutes here to get this principle of simplicity out, and then we're going to return to a very, very important point. Now, simplicity in metaphysics is not like simplicity, in your common sense language, right? It's not like something comes simply or easily to me, or something is simple in the sense of, a simple thought. What simplicity really means for the medievals is something which is so transparent to itself that it literally has no intrinsic or extrinsic boundaries. See, an extrinsic boundary is like a boundary as to space and time, right? So an extrinsic boundary would be something like something is in this place rather than in this place, right? And of course, that would mean that the reality was conditioned by the space which separated the two realities. So that's an extrinsic boundary. That space and the location within space, the magnitude of space, is actually a condition of the reality. And furthermore, it could be conditioned as to time, right? So this Queen Elizabeth or could be here and then there. Or, a cat could be alive and then dead, and so forth and so on. So the key thing to remember is, of course, that anything which is simple really means it's compatible. It doesn't have boundaries, either intrinsic boundaries or extrinsic. Extrinsic boundaries, that would be boundaries like space and time. It would be boundaries as to place. It would be boundaries as to square or circle, as to shape, or it would be boundaries as to the way of act, or intrinsic boundaries. So, an intrinsic boundary would be that it would be divisible into itself. Now, that has a very peculiar thing. And I want you to recognize one really, really important point here. And that is this. That when you get extrinsic boundaries and intrinsic boundaries, right, when you have them, they exclude other things from themselves. It's boundaries that do this. It's boundaries which make the principle of non-contradiction work. Just remember this. Boundaries and restrictions exclude. It doesn't matter whether you have intrinsic boundaries or extrinsic boundaries. They exclude. If you can get this, you can get the principle of simplicity, because simplicity is just the opposite. Simplicity means not having intrinsic or extrinsic boundaries, which means that simplicity is pure, absolute simplicity would be pure inclusivity, and degrees of simplicity would mean inclusive to other things. So when you have boundaries or restriction or finitude, you have exclusion. When you have simplicity, you have lack of either extrinsic or intrinsic boundaries, which means that you have inclusivity. It is inclusive to things. Okay, now, what I just want you to get a sense of for just a second here is that we've got then 2 possible options. And what I want you to understand is it doesn't matter what kind of boundaries you have. Once you have a boundary, you have an exclusion. Let's go back to square circle, which we saw in Unit 1. If something has the boundaries of a square, it cannot have the boundaries of a circle in the same respect at the same place and time. Good old Aristotle's principle of non-contradiction. But make no mistake about it. It wasn't because the boundary inhered in a block of wood. So the squareness inhered in a block of wood, and therefore you couldn't put the circle in a block of wood because of the wood. It wasn't that the squareness existed in a block of steel, and therefore you couldn't put a circle in the block of steel because of the steel. It wasn't because the squareness existed in my mind, and therefore I couldn't put the circle in my mind because of my mind. It's not because I'm stupid that I can't think of a square circle. It's not because of a limitation of my mind that I can't think of a square circle. It's because the boundary of square excludes the boundary of circle in the same respect at the same place and time. Literally, boundaries exclude. It's not that the electron is in my head or the electron is in that force field, and the proton is in my head or in a force. The key thing to see is that the boundaries of proton exclude the boundaries of electron and vice versa. Boundaries exclude. Where the boundary is doesn't make any difference. In your head, in a block of steel, in a block of wood, it doesn't matter. Boundaries exclude. And therefore, absence of boundaries are inclusive. They're the opposite. Now we have an interesting phenomenon in quantum theory. In quantum theory, light and electromagnetism, especially what we call electricity or electrons, photons would be like a particle of light. Light and electrons, they actually can manifest themselves in waves or in particles. I know this sounds absolutely bizarre, but literally, you can have light manifesting itself in what's called an interference pattern, right? That is to say, if you shine light into a box, and that box has a single slit that you're shining the light in, and then you have two slits, right? It actually, you can get an interference pattern on the back screen of that box because as the beam spreads out, it begins to form light waves out of both slits. And just like when you drop a pebble into a pond and you see the waves spreading out, and you notice that if you drop two pebbles in the pond, the waves interfere with each other, then you'll notice then that they actually, on the back of the screen, you've got some lighting, some non-lighting. And of course, you'll notice as well, right, that you have on, off, light, dark, light, dark, light, dark, because light acts like a wave. But we also have equally good experiments that show that light acts like a particle. It literally conserves momentum. You've seen those little toys where you take one of the balls, you may have 7 balls there, and you take one and it hits the rest of them, and only one shoots off. And it conserves momentum just like a particle would. You take 2 and 2 shoot off and so forth and so on. You've seen how that happens, and you'll notice that particles are self-enclosed. Particles conserve momentum. Particles do not interfere with each other. Particles do not spread out. And waves do spread out. And waves don't conserve momentum. And waves do interfere with each other. I mean, waves and particles are kind of like opposites. And yet we know that waves and particles can literally act, electrons and photons can actually act like waves and particles. Now, how is that possible? How can you have something acting in two contradictory ways? How can you do that? And we have to say that there's a tertium quid. There's a third thing. And the third thing is simpler. See, light doesn't really have the boundaries of a wave. And light really doesn't have the boundaries of a particle. Light is simple. Light is so simple that it can act like either a wave or a particle. It can have the boundaries of a wave or it can have the boundaries of a particle